Okie doke. Section 11.7, you should have a template. We have met these inverses before. This is just where it comes up in the function chapter. So, playing with our calc a little bit. Hopefully I can get you in the zone. Okay, so here's the scoop. If you recall, what is an inverse? An inverse is a reflection over the line y equals x. Basically, we switch the y's and the x's. So if I take y equals sine x, this guy right here, and I reflect it over y equals x, you'll notice what occurs. If you can imagine folding your paper along this line y equals x. Here's y equals x. So the problem, and where you kind of like to have things be functions, is that if we reflect the whole y equals sine x over y equals x, we suddenly get this new thing, this inverse that's not a function. It fails our vertical line test, and if you recall, the way that we determine that that would be a problem to begin with is if we look at our original function, and if it fails the horizontal line test, we know that we have trouble. So we have already explored this concept, which at times is a little sort of, I don't know, confusing maybe is the word I'll use, that we do this thing where we, what we call restrict the domain of the original function. So this is just an opportunity to do a little review of that. So we're going to take our original y equals sine x, and the way I taught this before is if you go back to your unit circle, and you're really just trying to grab, and we love quadrant 1, all happy, everything positive. You're trying to grab all the possible sine values out of your unit circle starting in quadrant 1. So I start in quadrant 1, I'm going to use that. Now oftentimes we're going to want to go quadrant 2. But the problem with quadrant 2 for sine is that the y values in quadrant 2 are exactly the same as the y values in quadrant 1. So that's why we want to use quadrants 1 and 4 for sine. So we restrict the domain then, and this is something that you are supposed to have in your brain, so it's a possible question you'll see on a Regents, to negative pi over 2 to pi over 2. And so we normally talk about this in terms of radians. And the range, hopefully you remember, I know we've had a break, so you might have not been thinking about this, but the range then goes from negative 1 to positive 1, because that's what goes on for sine, because the high point is positive 1, the low point is negative 1. And so when we think about this restricted domain on this graph, basically, if we want to think about negative 90, we're really just thinking about this part here, negative 90 to positive 90. And so hopefully you can see that when we do that, what happens when we do our reflection over y equals x is we get this little sort of wormy looking thing that is a function because it passes the vertical line test. And that's what you can see over here, and hopefully it's going to look better on your paper than it does here on my smartboard. And so just to continue with this then, when we do the inverse, so we get y equals sine inverse x, and recall what happens with domain and range when we do an inverse is they just switch positions. So the domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2. Now, in the end, drawing this function isn't as important as having the ability of using it, and usually when you use it, you do it on the main screen of your calc, and you don't even think about this cute little wormy thing right here, but that really is the function that's allowing you to do things like this. For instance, if I say, hey, the sine of some angle is 0.5. Now hopefully from all your time spent in this class you know then that the angle must be 30. But if you didn't, we use this inverse function and we say, well, what is the sine inverse of 0.5? And if our calc is in degrees, we come up with 30. Or if it was in radians, it's pi over 6. So this is a powerful thing because it allows us, if we're given a function value, to go the other direction. And so this function then, and I'm going to play with this on the calc here with you in a second, allows you to do that and think about it from that perspective. So let me just bring up the calculator. For starters, I'm going to put my mode into radians. And I'm going to hit my y equals, and I already have put in sine x and sine inverse x. And you'll notice what I've done here, just because it's, now you know, it's like this little slivery guy that's hard to see as I've made that bold. So I'm going to go ahead and start with a zoom trig here. And part of the reason I want to just hang out with a calc here with you for a minute is just to remind you that even though maybe this concept feels a little yucky, your calc will always sort of help you see it. So you'll notice then on your calculator you can see this little slivery guy right here, and it doesn't do this because that's not a function. That's not the best sketch of that, but it just is giving you where it exists. So if I wanted to actually sort of get my calc to look a little closer and just see the sliver a little better, I'm going to go ahead and hit my window button, and I'm going to type in my domain and my range of my inverse function. So I'm going to type in -1 to 1. And then I'm going to drop down here to my y min and y max and type in negative pi over 2 to positive pi over 2. And now I'm going to go ahead and I'm going to hit graph. And so first off, I'm seeing my regular sine function in this window. And then you'll notice, because I've totally locked down the window to the domain and range of the inverse, that I'm just seeing that inverse function. So just to play around with this a little, I mean, I'm going to go ahead, I'm going to hit my y equals here, and I'm going to get, I'll just turn off my original function so that I'm only looking at this, whoops, let me go back to my graph here for a second, so that I'm only looking at the inverse function. And because I think you can relate to it better, I'm going to just for a moment here change my mode to degrees, actually, because I think you're going to relate to this better. Which means I'm going to go in here to my window, and I'm going to change this, instead of in radians, I'm going to change this to -90 to +90. I just want to show you what is going on here. So remember, this is my inverse function. So I can hit my trace button and I can say, well, what do I do with this inverse function? Well, in this case, okay, if you notice, and this has happened to me, it might be a good lesson for you too. If this comes up where it says plot 1 like that, I want to turn my plots off because they're going to get in the way here. So I'm going to hit second stat plot here and turn my plots off and go back to my graph. Okay, so if I'm using the function directly, the actual graph of the function, and this is my inverse function. So if I hit my trace button, remember I'm in degrees now just so you can relate to this a little bit better. This would be a case where someone says, hey, there's an angle and its sine is a half. So if I type a 0.5 in for my x value in this case, it gives me 30. Likewise, if someone says, hey, there's a sine and its sine value, its function value is radical 3 over 2, if I type in radical, whoops, hold on a second, trace, hold on, I'm having a moment here, hit trace here. Okay, so I'm going to type in radical 3. Okay, something interesting is going on here. Let me just check something here. My plots are off. Okay, I'm going to hit trace again. And I'm going to type in, hopefully this is going to work. It should, and I don't know why it's not right now. Now the radical came up, and I might be having a little smartboard issue. Okay, so I'm going to actually type in radical 3 over 2 into my x. And notice out comes 60. So these things that you naturally do on the main screen of your calc are really truly related to this function. This is the point that I'm trying to get across here. Okie dokie. So there, that's sine. Now I'm not going to spend as much time on cosine because it's a similar situation. I'll just do a quick review as far as the restricted domain then. So y equals cos x. And just a quick sketch here so you can think about the unit circle, what goes on. Well, quadrant 1, my x values are positive, and quadrant 2, my x values are negative. So quadrants 1 and 2 are perfect to restrict the domain in order to do this guy, because in this case I can pick up all my cosine values in quadrants 1 and 2. So my restricted domain then in this situation is going to be from 0 to pi. And once again, cosine has the same range, and so it goes from -1 to +1. Therefore, when I do my reflection over y equals x, my domain then is going to be -1 to 1, and my range is going to be 0 to pi. And rather than spending the time here on the video, I would suggest to you that you could do the exact same thing that I just did with sine if you want to take a look at cosine. And you'll notice that y equals cos inverse is sketched on your paper with some of the points there. So this is just sort of the graphing, the graph of cos inverse, which oftentimes you're just using on your main screen. Okay, tangent, if you recall, is a little bit different in its appearance just to begin with. So when we do our inverse of tangent, it's going to have a different look also. And you can see it over here in all its glory. And so just as a quick review about tangent and its restricted domain, remember quadrant 1 is our happy quadrant. And just to review as far as what's going on with tangent, since we're not thinking about x's and y's, we can remember all students talk constantly. So tangent is positive in quadrant 1, and it's also positive in quadrant 3. So that quadrant 2 and 4 are where it's negative, so we're tempted probably to go to quadrant 2, but if you remember that at 90 degrees tangent does not exist. And so because of that, and you can see that on this graph here, because really can't really see it on the graph, there's a thing called an asymptote here, because tangent can never actually have a value at 90 degrees. So we need to use quadrants 1 and 4 for tangent. So y equals tan x. The restricted domain, we're going to use quadrants 1 and 4, so we describe that as negative pi over 2 to pi over 2. And remember, something different's going on with the range of tangent. Tangent is going in both directions up to positive infinity and negative infinity, so the range then is all reals. So then when I come over here and I get my tan inverse, once again, I'm just going to flip my domain and my range. The domain then is going to be all reals, and the range then, bring that down here, is going to be negative pi over 2 to pi over 2. And you can see here in this picture that the domain is all reals, because this is going to negative infinity and positive infinity, and as far as the range, you can see it's going up to pi over 2 down to negative pi over 2. Once again, I'm not going to do it on the video. I would suggest you put this into your y equals and play around with it and see what your calc shows you when you do tan inverse on the calculator. So once again, in this example down here sort of reinforces it. Most of the time we're not really using the actual function on the graph, but we need to be aware that there is a function, and that's what we use to do problems such as this example. So, example, find in radians all values of theta such that tan theta equals negative 1.20000. In the interval from 0 to 2 pi. Express the answer to 4 decimal places. So, hopefully at this point you would just naturally say, oh, I can do that, that's easy. Theta is equal to tan inverse of negative 1.200. And you go to your main screen, and your brain's not even thinking about this beautiful graph up here, because your calculator will do this right on your main screen. And so we're going to go to our main screen, and we're doing this in radians. And remember, the whole idea here, now that you know about degrees and radians, is always making sure you know what mode your calc's in. And I'm currently in degrees, so I'm going to change this back to radians. And now I'm going to clear my main screen, and I'm going to type in second tan, and the number that I'm given, negative 1.2. And I hit enter, and out comes a yucky decimal, which I'm going to round to 4 decimal places. So when I come back here, I get negative 0.876 rounded 1. But I am supposed to be between 0 and 2 pi. So in reality, this value, if you recall, is going to be an angle that's going to be hanging out over here in quadrant 4. Just if you remember, and once again, I know we've had a break, but 1 radian is approximately 57.3 degrees. So when you think about this negative, it's not quite negative 1, but it's definitely going to be in quadrant 4. So what do I do then to get this so I meet the requirements of the problem? Well, I'm going to take that negative 0.8761, and I'm going to put a wrap on it, because basically what I want to do is I want to give it in terms of a positive number. Now a wrap in radians is 2 pi, so I'm going to add 2 pi to it. And that turns out to be 5.4070. Okay, now here's another little blast from your past, perhaps, and that is the fact that not only will I find a tangent value that's negative here, but there's going to be one up here too that meets the requirements of this that's been served up to me. So I need to figure out, well, what is this angle? And so basically, if you think about it, that angle there is just going to be 180 degrees minus what this equals, which we know what this equals because our calc told us. So, and remember, we're doing this in terms of radians, so I'm going to take pi instead of using 180, and I'm going to subtract this measure here, which was 0.8761 minus 0.8761, and then that is equal to 2.2655. And there you have it. Okay, so once again, we use these inverse functions all the time on our main screen, and we oftentimes don't think they're really coming from a function, and so that's the connection that we're trying to make here. So head on over to MathXL. There's some problems for you to work on. When it asks you to use exact answer, I think it like says answer in radians. Remember, you're going to want to, even if you're in degrees, you want to turn it into radians, as in, for instance, 30 degrees is pi over 6 radians, etc.